I'm Dave Mills, Lead Data Engineer for the Research Methods Support Team. And over the next 10 minutes, my goal is to get you excited about some of the things we've been doing with IT systems for data information and knowledge management within RMS. There's a lot to cover here, so I'm just going to give a few highlights of the work we've done over the last few years. But first, we need a bit of context. Around 6 years ago in RMS, we were talking about the concept of data loops as an extension to the standard data flow in research, where we could use automation and cloud-based tools to make it easier to achieve the main goal of presenting useful information to the right people at the right time. We spent a lot of time exploring this idea, both internally and in collaboration with projects across CCRP, and based on this learning, we've built a series of platforms and templates, and I'd like to show you some of them now. First up is the Yanapai's Potato Variety Catalogue, and we've worked with the Yanapai team to create this platform. This is a web system, and it manages data on nearly 4,000 potato varieties, which are kept and grown by the Association of Native Potato Guardians across Peru. It includes a database of the varieties and their properties. It also links to ODK to allow new data into the system. It allows the Yanapai team to curate that data. And it includes a front-end catalog page to let users explore the curated data in different ways. This platform was officially launched by Yanapai earlier in the year, and it's had interest from quite a few places, including the International Potato Center. And there's a lot of potential to continue development of this system with Yanapai, which I'm pretty excited about. But to me, what's really exciting is the potential for this platform to be used as a template for other crop variety catalogs. Nothing about the core infrastructure here requires this to be specifically about potatoes. The system could be adapted for maybe a sorghum variety catalog or quinoa. The list of variety properties can change quite easily, and the design can also change without affecting the core system. And this would make it much quicker to build a second catalogue than it did the first. Also, because it uses ODK, it's also possible to modify the data collection tools separately from the rest of the system, making it easier to collaborate with research teams on the development of tools. The next system is the Weatherstations Platform, and this is a tool for capturing, storing, and processing data from a network of weather stations across the Andes region. Working with UMSA and Prosuco, we've built tools to upload large historical data sets extracted from individual stations over the past 15 years, and to stream new data in near real time from stations connected to the internet via a system called MeteoBridge. And the result is a consolidated database of raw metadata, and a system that automatically generates summaries at daily, 10 daily, monthly, and yearly levels. And these summaries are made available for download. The system also includes a set of scripts written in R to generate a variety of graphs, which can be used to explore the available data. The user can customize these graphs to their needs through the web page shown here, and the graphs can be downloaded as image files. But the really exciting part is how we can extend this system. On the server, these graphs are just R scripts that query the database. So if you can write an R script that can process data in one of the formats we have and generate a useful product, we can potentially include it into the system. As an example, we've so far written and added an R script to estimate evapotranspiration at each station site from the raw data. It's also quite easy to add new weather stations into the system to expand the network. And finally, Prosuco are working with farmer networks that share observations by WhatsApp, and we're keen to explore how these observations could be brought into the system as a way of bringing together metadata with agronomic data and observations from the same region, with potentially powerful results. Next up is the Soils Data Platform, and this is actually one of the first web-based data systems we built in this format, and it's formed the template for many systems that have come after, including parts of the previous two platforms. This platform's core function is to let projects deploy the ODK forms built from the Soil Health Toolkit to collect soil sample data and run analyses. It works like this. Every project has access to the same form templates, but when they deploy them, they get unique instances of those forms, And this is important, as it means each project retains full ownership and control of their data throughout the collection process. The form deployment is managed by the project, so they can control which forms they use and when. And the fact that they use the same collection tools means every project's data is in basically the same format, which lets them automatically contribute to a combined dataset, which the Soils cross-cutting team can access. And I know they've got some very interesting ideas about how this dataset can be used as it grows. And as for the projects, they get some free data management, as the platform automatically merges data from all of the forms together into a single sample-level dataset, which they can download in a couple of different formats. Finally, I want to quickly showcase a different type of platform. The previous three systems provide tools for supporting research, data collection, management, and generating information products. Our resources platform starts where the others end, providing tools for curating information products, tools, and other resources. The platform has tools for searching and filtering the collection on the front end, which are similar in many ways to the potato variety catalogue. And on the back end, it has tools for the management of the resources themselves, which is accessible via a login. What excites me here is that, like many of our other platforms, this one is built with the intention of extending it in various directions. One extension we're currently working on was mentioned in the previous presentation. The syllabus that Alex and Nuru described is a framework to guide learners to relevant resources from our resources database. The completed syllabus will have a separate front end, but will still link to the same database of resources, and because of this, can automatically be updated as we expand and update the main resources collection. So what does all this mean? We've built this series of unique custom systems to help particular projects. But there's more to it than that. First, every platform here is built using the same set of tools. You'll notice both ODK and R play prominent roles in many platforms, which is important as these are tools that are used across CCRP. And, as you've heard, we provide training and support for these tools. MySQL is a commonly used and very robust database system. And the glue that brings it all together is a framework called Laravel, which runs using PHP. This has a very large user base and a very active community developing open source libraries and tools that we can integrate into these systems, and we've done that for a number of these platforms. You may also notice that many of the functions of these platforms are similar, and this is very deliberate. For example, the platforms allow management of access to data and information via user accounts and team memberships or user roles, which ensures data privacy and ownership issues are addressed, and allows easy sharing of data and resources when needed. These platforms can also be linked to external systems, either via direct database access or through a custom-built API, for example, to bring data together from different sources. And Laravel lets you quickly write simple APIs for this purpose. And then there's the link to ODK. We've found that the challenge posed by the Soils team, the idea of having multiple teams using the same set of form templates to generate harmonized data, while still retaining ownership of that data, is a very common one. So common that we've built a package specifically for this type of setup, and have so far used it in around 7 or 8 different systems, both within and outside of CCRP. This includes a platform built for the CG's Agroecology Transforming Partnership Program to support a set of 12 case studies exploring the viability of agroecological practices across Africa. And there's also interest from other groups, and we're working with RMS to extend this system even further. But this system isn't limited to research support. We found it useful in supporting IOM with an impact evaluation of a reintegration program across 3 countries and with multiple forms. We were able to support these projects beyond CCRP as a direct result of the work done with RMS, and thanks to our learning with IOM and others, we've got a pretty good idea of how these systems can be used to support monitoring of ongoing activities, such as agroecological transformations. And that's what really excites me about all of this. Thanks for listening.